Hello and welcome to section 10.6, which is on circles and arcs. And so the first thing we need to do is just remind ourselves of a bunch of the terms that go with circles. They should be, for the most part, review. A circle is just a set of all points and equidistant from a given point called the center. The diameter is a segment that contains the center of the circle and has both endpoints on the circle. So in other words, the whole way across the circle. Radius, a segment that has one endpoint at the center and the other endpoint on the circle, halfway across the circle, in other words. Central angle is an angle whose vertex is the center of the circle. A semicircle is half of a circle. A minor arc is smaller than a semicircle, and then a major arc is larger than a semicircle. And so here I have examples for you. So A to C, right here, that's obviously a radius, starts at the center and goes out. D to B is the whole way across the circle, and it does go through the center. It has to go through the center, otherwise it's not called a diameter, or it would be called a chord. Angle BAC, so this one right here is a central angle. This right here would also be a central angle. B to D, so B all the way across here to D is a semicircle. B to C, since it's less than a semicircle, is called a minor arc. And then D, and I'm going this way, D all the way around to C is a major arc. So some measurements that we can figure out because of this. A semicircle, it's 180 degrees, it's half a circle. A minor arc is the measure of the corresponding central angle. So if up here, if I told you this central angle right here was 62 degrees, and you wanted to know the measurement of arc BC, you would say it is also 62 degrees, corresponding angle, central angle. Major arc is a measure of 360 minus the related minor arc. So if you wanted to do D all the way around to C, and you knew that this was 105, you would take 360 minus 105, and then you could get it. Adjacent arcs, arcs of the same circle that have exactly one point in common. So in other words, arcs that are connected. So for instance, B to C, C to D, those would be adjacent. They're sharing point C. Postulate 10.2 says, the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs, which would make sense. Like I just said up here, if I was trying to get BC and CD, I would add them together, what those two are. So the measure of ABC would equal the measure of the arc AB and arc BC together. And so here I have an example. So what is the measure of each arc in this circle that I have drawn here? And I have a couple angles in there. So we have PR, C, Q, and S, and here's 28 degrees, and this is 77. So measure of arc PR. And I probably should have drawn in the little, you're supposed to have little arcs above them so that you know it's an arc. So the measure of P to R would be the measure of this corresponding central angle. So then you know it is 77. Measure of R to S. So from here all the way around to here. Well, you can see that from P to S is a semicircle. So you could just take 180 minus this piece, and that would clearly show you that that has to be 103 degrees then. PRQ. So P through R all the way around to Q. Well, I know that P to S is 180, and then I have another 28, so I can just add that on, and it would be 208, 208 degrees. P, now I'm going the other direction, so P through Q all the way around to R. I would have to do, the whole circle is 360 minus this 77 that's left. That would leave me with 283. So you can use the fact that the whole circle is 360 and that half of it is 180 to figure out all the rest of these, the angles that they're asking us about. Circumference, we've done that quite a few times in the past. Just a reminder, it is pi times diameter. Remember that if you have the radius, you have to double it first and then take it times pi. A concentric circle, coplanar circles that have the same center. Here I have an example. What is the circumference of a circle with a diameter of 8? Well, that's pretty straightforward. You just have to use the formula. So C equals pi d, and we know that for pi we're just going to go ahead and round it and use 3.14. My diameter is 8, so all I need to do is multiply those two things. So 25.12 centimeters is my circumference. Remember that circumference is not labeled with a 2. It is not square centimeters, because circumference is like perimeter of a circle. You're just walking around the circle and adding it up. An arc length is a fraction of the circumference. So theorem 1010, arc length theorem, states that the length of an arc of a circle is the product of the ratio measure of the arc divided by 360, or over 360, and the circumference of the circle. So I'm going to multiply however much of the circle it is, the measure of the arc over 360 times the circumference. So my example says, what is the length of a semicircle with a radius of 1.3? Okay. Well, the first thing I have to do is realize they're giving me radius, and I don't need radius, I need diameter, so I need to double that. So 2.6 is my diameter. So it says the length of a semicircle. So a semicircle is 180 degrees, and then you put it over this 360, and you take that times the circumference. So times pi times my diameter, and we could easily reduce that to 1/2 and make it easier on ourselves. So I'm going to go ahead and take half of 2.6 again, just to simplify it. So 3.14 times my original 1.3, because I divided it by 2. Multiply that out, you get 4.082 meters. Again, not squared, because it's just one length. It's not like area or anything like that. So bring that knowledge of circles with you, and we will talk about it more the next time I see you. Have a good